Okay. So we talked about, what was the first one? How we got our stuff, how we got the data. Okay. And then we made a bunch of distributions. We made graphs. We made histograms or frequency graphs.
When was this class?
December 20th. Or something like that. I have it. We have stem and leaves plots. Okay? And then we said we better look at these things. What's in the center? Is there anything unusual? What shape does it have? And what's the spread? And so we did central tendency is the 4 M's. Mean, median, mode, mid-range. All ways of finding the center. Now we're interested in how far out is the data spread. So if you were a school teacher and you had 10 kids in this class, would it be easier to teach that class if they were all equal intelligence, or if they were all spread out, like you had some really bad just exactly, so it's much easier. So if it's spread out, there's some differences in the world. Okay, so we're going to look at some numbers and we're going to find some different ways of measuring spread. They call it the measures of dispersion, which is dispersion is a great word. So the first one is the range. The range is just the difference between highest and lowest. And so range is equal to high minus low, or you can say it max minus min. Piece of cake. Easy to do. So here's a bunch of numbers, a little pop quiz, and the range of this, the high was 10 and the low was a 6. So the range is 4. Okay. So, ready? Now it says, let's do the mean, median, mode, mid-range, and range of these. So, the mean is 50, right? X bar is 50. Don't you think? Yeah. The mode, mean, mode, none, nothing repeats. Mid-range, does anybody remember what mid-range was? Oh, I forgot median, sorry. Median is also 50. And then the range, we can do a range quite easily. 52 minus 48, which is 4. What's the mid-range? Does anybody remember that one? Mid-range formula? You add the atom, max plus min divided by 2. So 48 plus 52 is 50. The mid-range is just the average of the biggest and lowest. Don't get it confused with the range. And it does, but they're on your formula sheet, so you don't, just follow the formulas. Okay, now let's look at this one.
Wait, what?
Oops, sorry. There we go. All right, I'm going to use my calculator, because this looks a little bit more interesting. Not that calculator. $73 plus 29 plus 71 plus 90 plus 21 plus 16 divided by 1, 2, 3, 4, 5 divided by 6 is equal to 50. So the mean here is 50. The mode, anything repeat? None. Mid-range. Here's the max. And there's the min. So 90 plus 21 divided by 2, 55.5. The median, let's see if we, oh no, it's plus 16. Dang it, that's wrong. Why did y'all stop me? 90 plus 16 divided by 2 is 53. Okay, so if I put these in order, 16, 21, 29, 71, 73, 90. I put them in order, and so the median is the average of these middle two, which is 29 plus 71 is 100, divided by 2 is 50. And the range is 90 minus 16, which is 74. So the point of this, two sets of data, same mean, same median, very close mid-range. And if I would have done this problem better, it would have had the same mid-range. But the range, definitely different. One's spread out a long ways. Okay, so range is one way. But there's a better way. Because really, range only uses two values, right? It only used two of the 6 values. This only used 2 of the 5 values. What if there was 100 values and we only really cared about the shortest person and the tallest person, the fastest person and the slowest person, right? What about everybody else's time? Well, there is a way that everybody gets a little bit of skin in the game, a little bit of weight. And it is called the standard deviation. You will have to do this on your homework. And I have put it on a test with a little bit of helps, like a table that help you work, like this table to help you work your way through it. But basically it takes every single data point, sees how far that data point is from the mean, squares it so that the negatives become positive, adds them together, divides, and then takes the square root. Because we squared everything, now we have to take the square root of it. So it's a really, really weird formula. Okay? In fact, here's the formula. It's fantastic. It really is. It basically says take every x, subtract the mean from it, from every single x, square that, add them all up, and then divide by 1 less than how many points there are. And there's some y, you had to do n minus 1 instead of n, not part of this class. So here we go. So here's our pop test scores, right? 8, 10, 9, 9, 6, 8, 7, 9. Okay. First step, find the mean of those. So what do we got? 8 plus 10 plus 9 plus 9 plus 6 plus 8 plus 7 plus 9. 66, 1, 2, 3, 4, 5, 6, 7, 8. Divided by 8 is 8.25. All right, boom, already step 1, done. Here we go, write down the data items. 8, 10, 9, 9, 6, 8, 7, 9. Now, find the deviation. How far each of these points is from x bar. So this would be 8 minus 8.25, which is negative 0.25. This is 10 minus 8.25, which is 1.75. 9 minus 8.25, which is 0.75. 0.75. 6 minus 8.25 is negative 2.25. Alright, we already got the 8, negative 0.25. We don't have a 7. And a 9 we already had is 0.75. Now the one on the test will not be this many data points, and everything will come out to be nice integers. No decimals. On your homework, I cannot promise you small data sets, nor can I promise you non-decimals. But you'll get it. Alright, guess what? Now this is not part of the whole course, but guess what? What happens if I add all these up? You get the mean, and you basically, if you add them all up, you get 0. Because some are above, some are below, and they're going to average out to be 0. So the sum of all the deviations is 0. Once again, probably not part of this course. Okay, so now we got to square all these things, get rid of the negative sign. So 0.25 squared is 0.0625. 34 times 9. I'm just going to have to use a calculator. It's Monday morning. So this is 3.0625. This is 0.5625. 0.5625. This is 5.0625. 0625. .5625 and 0.5625. Okay, so all I did was square these numbers. And now they're all positive. Okay, the next step is add them all up. So, grab a calculator, because I can have a calculator. What's the odds that we'll type this in? There's 2 of them. I got 11.5. It's nice. Not too bad. Okay. Next step, step 5, divide by n minus 1. So there's 1, 2, 3, 4, 5, 6, 7. There's 8 data. So n is equal to 8, so I'm going to divide by 7. So 11.5 divided by 7 is equal to 0.2054, approximately. And then it says take the square root of that. Nope. And that is equal to 0.4532. Now, is the standard deviation big? Is it small? It's very relative. Kind of take that and compare it to the mean, which was 8.25. And basically we're saying that the average point is 0.45 away from 8.25. The average point is about 0.45 from there. Now some of them are further. The 6 was that one did a lot of damage to the standard deviation, and so did this one. The 10 and the 6. Everybody else was fairly close. Okay, so it's a very relative type of term. Is that a big? Is that a small? Who knows? But that's what you used to have standard deviation. You all ready to try one more? One that will look like the actual. Oh my goodness, there's a lot in this thing. Is this the next unit? Oh, that must be 12.4.
12.4 and 12.3 software.
Oh, there it
Back
is.
of this page.
Oh, okay. I was wondering. It's like, man, 12.4, that's a lot of stuff. I didn't make a good page break. Okay, so let's do it one more time. Standard deviation. 4 numbers. What's the mean? 6, 13, 24. Divide by 4 is 6. Did you get that? Okay. So the mean is 6. We write down the data values. 2, 4, 7, 11. We find out how far each one is from the mean. So 2 minus 6, 4 minus 6, 7 minus 6, 11 minus 6, negative 4, negative 2, 1, and 5. I think we can do this whole thing without even using a calculator. Maybe. We'll see. Square each one. X minus x bar. And if we added all those up, they would be 0. So we did this right. Negative 4 plus negative 2 plus 1 plus 5 is 0. So that's a good check to see if we did those right. So we're going to square each one of those. And that's 16, 4, 1, and 25. We're going to add up all those. And that's 21 plus 25, 46. You get 46, 20, 21, yep, 41, 46, okay? And then, oh wait, now we're going to divide 46 divided by n minus 1, which would be 46 divided by 3. I wish that would have come out to be a nice number. Oh well, 46 divided by 3, time to go to a calculator. 46 divided by 3 is 15.3 repeating. And then we take the square root of that. And we get a standard deviation of 3.916 ish. You might see standard deviation SD. You might see S. I don't know. Do you like my little cartoons in here? Are they cracking you up? Okay. Smokers are less likely to die of age-related illnesses.
What did you say?
All right. So remember that data from the very front, where it had the same range, no, same same mean, same mode. 50, remember that earlier? Well, we actually calculated the standard deviations of those two, and the top one was 1.58, and the other was 31.39. You see how this is a wide standard, big standard deviation. Each point varies greatly from the previous one, from the mean. Okay, so we're going to stop there. Short lesson.
Right.
That's it. We are going to review Wednesday.
Super long.
Review Wednesday, test Friday.
Oh,
Are we okay?
yeah.
All right, so Friday is the half day.
Test Friday.
Test Friday.
Lesson. So this is the half day or week?
Yeah, we're going 1 through 5 Friday. So we will test on Friday.
Are we on pep rally stuff?
No, away game.
Yeah.
No pep rally games.
I mean, I
I
can
didn't
make
know
one